In this example, we are given that 2 moles of helium are initially at temperature 27 degrees centigrade and occupy a volume of 20 liters. And it is saying the gas is first expanded at constant pressure, that is isobarically, until the volume is doubled. And then it undergoes an adiabatic change until the temperature returns to its initial value. And it is asking us to sketch the process on PV curve, and we are required to find the work done by the gas. Now, in this situation, here if we start, we are given with the number of moles which are 2. Initial temperature of the gas is 27, so its absolute temperature will be 27 plus 273, that will be 300 Kelvin. And its initial volume is given as 20 liter, that we can write 20 into 10 to the power minus 3 meter cube. If we draw the state diagram of the gas, in initial state, its pressure, volume, temperatures are P1, V1, T1. Now it is saying there is an isobaric process in which pressure was kept constant. So in the final state, pressure remains same V1, and it is saying the volume changes to twice the initial value. So volume will be 2V1. And as we know, as pressure is constant, we can use Charles' law as V1 by T1 is equals to V2 by T2. So volume gets double, temperature will also get double. So here temperature will be 2T1. And finally it is saying it undergoes an adiabatic change. So if an adiabatic process is followed, then in adiabatic process it is saying the temperature returns to the initial value. That means in the final state, temperature got back to the temperature T1 again. Pressure will change certainly to P3, and say we consider volume to be V3 in the third state. For adiabatic process, we can relate temperature and volumes as T V2 power gamma minus 1 is equals to constant, which is the pressure equation for an adiabatic process. And here if we use it for state 2 and 3, so here we can write 2T1 multiplied by 2V1 to power gamma minus 1, as the helium is a monoatomic gas. And the value of gamma in this situation will consider as 5 by 3. So gamma minus 1 will be 2 by 3 is equals to, in final state temperature is T1 and the volume is V3. So it can be written as V3 to power gamma minus 1, which is 2 by 3. If we simplify this to get the value of V3, as here T1 gets cancelled out, we can see the value of V3 we are getting is 2V1 multiplied by 2 to power 3 by 2, which will be 2 to power 5 by 2 V1. This is the volume in the final state of gas, which we certainly need here to plot the process on PV curve. And if we just talk about the work done in the two processes, in the first process work done W1, we can directly write, as we know in isobaric process, work done is given as NR delta T. So we substitute the values, number of moles are 2, the value of R gas constant we can write 8.314, and temperature as it is getting double, it will be 300, because in this state temperature is 600 Kelvin, here it is 300 Kelvin, and finally again the temperature becomes 300 Kelvin. On simplifying this, we are getting the value of work done as 4980 Joule. In the second process, if we calculate the work done W2 as being an adiabatic process, work done we can write, which is given as NR by gamma minus 1, it is delta T. So in this situation, if we substitute the value, it is 2 into 8.314 by gamma minus 1, thus 5 by 3 minus 1 is 2 by 3 multiplied by delta T. Here actually this delta T is T1 minus T2. If you can recall, we have studied in an earlier section about the work done in adiabatic process. So here this will also be 300. So in this situation, if we calculate the value, then the value of work done we are getting is 7470 Joule. Now if we find out the total work done by gas, this can be written as W1 plus W2, that is 4980 plus 7470. The value we are getting is 12450 Joule. That will be the answer to this problem. On our next sheet, let us continue and draw the whole process on the PV curve for this situation. Now in this case, if we plot the ID curve for the complete process, we can see here we plot it on PV scale. We are given that initially, say the gas pressure is P1. It is given that the volume is V1, that is 20 liter, and the temperature here is 300 Kelvin. Now in this situation, initially the process is isobaric, so it will be a horizontal straight line. You can say till the volume changes to V2, which is 40 liter, because it is given that in state 2 its volume is doubled. So obviously here temperature will be 600 Kelvin. Now it is saying from a state 1 to 2 it is undergoing with an isobaric process. Then it executes an adiabatic process till the temperature get back to 300 Kelvin. That means if we plot an isothermal curve passing through state 1, it must also touch state 3, where temperature again changes to 300 Kelvin. This curve can be written as an isotherm, which is passing through 1 as well as 3, because both the points are at same temperature. And here we can just write down the final volume, which is V3, which is equal to V1 into 2 to power 5 by 2. So this can be written as 20 multiplied by 2 to power 5 by 2 liter. And in this situation, the pressure in the final state is P3. If required, it can easily be calculated by using the process equation of adiabatic process in PV or PT. In this way, we can finally plot this curve. Just carefully have a look on the situation and understand it very carefully.